Scientists just found a single subatomic particle with as much energy as splitting 1 billion uranium atoms. And the craziest part, it traveled through the entire universe without hitting anything, until now. Deep beneath the Mediterranean Sea, scientists have detected the most energetic ghost particle ever discovered. This tiny neutrino, a particle so small it's essentially nothing, somehow carried more energy than anything we've ever created on Earth. It's like finding a ping pong ball with the power of a nuclear bomb. These so-called ghost particles earn their spooky name because they're practically invisible to the universe. Right now, about 100 trillion neutrinos are passing through your body every second, and you feel absolutely nothing. They can travel through planets, stars, and entire galaxies without changing course. What makes this particular neutrino special is that it has more than 30 times more energy than any neutrino we've ever seen before. By the end of this video, you'll understand how this mind-boggling discovery might completely change our picture of the most violent events in the universe, from supermassive black holes to cosmic collisions that dwarf anything we can imagine. And I'll explain why some scientists didn't even believe it was possible. To catch a ghost, you need a special kind of trap. And in this case, it's not some contraption from Ghostbusters. It's actually a massive array of sensors called KM3 net, suspended 11,300 feet beneath the waves of the Mediterranean Sea. Here's the thing about ghost particles. They're incredibly hard to spot. The detector doesn't actually see the neutrino itself. Instead, it waits for the rare moment when a neutrino does something almost unheard of. It bumps into another particle. When that happens, it creates a special particle called a muon, which then triggers a beautiful cascade of blue light that the sensors can detect. It was just another day for the detector, which was actually still under construction. Then suddenly, on February 13, 2023, a single muon crossed through the entire detector, lighting up a third of its thousands of sensors. Scientists knew immediately this was something special. When they analyzed the data, it wasn't just special, it was historic. This particle, now named KM3-230213A, had come in from the side at a nearly horizontal angle. This told scientists something crucial. It had traveled through about 87 miles of rock and water before reaching the detector. Only a neutrino could do that, and not just any neutrino, but one with unprecedented energy. So what exactly are these ghost particles? Neutrinos are fundamental pieces of our universe. They're everywhere, but they interact with almost nothing. They have virtually no mass and no electric charge. If an electron were the size of an apple, a neutrino would be smaller than a grain of sand. Yet they're absolutely essential to how our universe works. About 100 trillion neutrinos are passing through your body every second. That's more than all the grains of sand on Earth. And you never feel a thing because they almost never interact with the atoms that make up your body. In fact, a typical neutrino could pass through a light year of solid lead without hitting anything. Scientists have identified 3 flavors of neutrinos: electron, muon, and tau neutrinos. They're named after the particles they're associated with. What makes them even stranger is that they can actually transform from one type to another as they travel through space. Since these particles hardly ever interact with matter, catching one is incredibly difficult. That's why scientists build these massive detectors deep underground or underwater. They're trying to shield the detectors from all other particles so that when the rare neutrino interaction does happen, they can spot it. It's like trying to hear a whisper in a hurricane. So what makes this ghost particle truly extraordinary is its energy. Scientists measured it at about 120 quadrillion electron volts. That's a number so large it's basically meaningless to most of us, so let me break it down. This single subatomic particle carried 30 times more energy than any neutrino we've ever detected before. To put this in perspective, the most powerful particle accelerator on Earth, the Large Hadron Collider, can accelerate particles to about 7 trillion electron volts. Our ghost particle had 30,000 times that much energy. You'd need a particle accelerator that wrapped around the entire Earth to create something this energetic. But here's the mind-bending part. All that energy was concentrated in something smaller than a trillionth of a dust mote. This unprecedented energy level isn't just an interesting factoid, it's a game changer for physics. It tells us that somewhere out there in the universe, there are natural cosmic accelerators that can produce energies far beyond anything we can create on Earth. But what kind of cosmic monster could create something like this? Scientists are confident about one thing: it didn't originate in our Milky Way galaxy. By measuring the direction the particle came from, researchers traced its path back to the edge of our galaxy, but found nothing there that could have created such a powerful neutrino. This means our ghost particle traveled across vast intergalactic space to reach us. The leading suspect is something called a blazar. Imagine a supermassive black hole at the center of a distant galaxy, actively devouring matter. As it feeds, it creates intense jets of particles that shoot out at nearly the speed of light. When these jets happen to point directly at Earth, we call it a blazar, and it's like having a cosmic lighthouse beam aimed straight at us. There's another possibility that's equally fascinating. Our ghost particle might have been born when an ultra-high-energy cosmic ray, likely a proton, slammed into a photon from the cosmic microwave background. This background radiation is everywhere in the universe, left over from shortly after the Big Bang. If confirmed, this would be the first ever detection of what scientists call a cosmogenic neutrino. But the detective work isn't over. Scientists have identified 12 potential blazars that lie in the general direction this neutrino came from. But pinpointing exactly which one sent this ghost particle our way is incredibly difficult. It's like trying to figure out which star a particular photon of light came from when all you know is the general region of the sky. This discovery is opening a whole new window into the universe. Scientists call it multi-messenger astronomy. Think of it like this. For centuries, we only studied the cosmos through light. Then in 2015, we detected gravitational waves for the first time, ripples in space-time itself. Now, high-energy neutrinos give us a third way to observe the most powerful events in the universe. Not everyone was instantly convinced by this discovery. After all, another major neutrino telescope called IceCube in Antarctica has been hunting particles for over a decade and never found anything this energetic. Some scientists asked, how can this be possible without IceCube having seen something similar before? This healthy skepticism is part of what makes science work. Extraordinary claims require extraordinary evidence. And what's even crazier is that the KM3 net detector that caught this ghost particle was only operating at about 10% capacity when it made this discovery. As the detector continues to be built out, we might start finding even more of these ultra-high-energy neutrinos, helping us solve cosmic mysteries that have puzzled astronomers for decades. Don't forget to watch the video on the right and subscribe. Thanks for being part of Cosmoknowledge.